สวัสดีค่ะ Good morning again. Today we are going to be doing a topic on Y and delta transformation. This is a method that if you have connections of your elements in a Y or delta configurations, maybe you can transform to make your circuit simpler to see and analyze. Okay, so let's see what are the Y's and what are the deltas configurations. Okay, so therefore I'm start. Well, we can have two form of the same network. Okay, so therefore the Y is actually look like a Y. It could be, of course, actually like Y like this, or it could be an upside down Y also. Okay, so there's a terminal A, B, and these are C, right? So you have a resistor in this case, right? It's transformed when you connect the resistors in the Y configurations. Okay, so this is the Y. Okay, same thing if you draw it like this. Okay, so these two are the same. Okay, A, B, C, R1, R2, and R3. Oops, what happened? Hold on. R3, oops, R3. Okay, so this is called a T configurations, right? Okay, Y and a T, they the same. Okay, and these two are the same. And another one, delta. Okay, so these two are also the same. Okay, so the delta, so like a triangle, this. Okay, so this is lead A, B, C, and we label your resistor as, well, RA would be the diagonal to the terminal A, so RA. Okay, so diagonal to B is RB, and diagonal to terminal C is RC. So this is delta connections. Okay, right? Another one that's of the same so-called same configuration is called the pi. See, it looks like the pi, right? Look like pi like this, right? Okay, so this is the pi configurations. Okay, terminal A, terminal B, and terminal C. So opposite to terminal C is RC, right? Opposite of B is RB, and opposite A is RA. Okay, so these two, right? So now we're going to learn how to convert from one to the other. Okay, so simply said Y to delta and delta to Y. Okay, so there's of course formula, okay, to remember, okay, which is you have to go and find out how you would a way to remember this. Okay, so I'm going to start it like this. Okay, this is C, B, A. So if this is opposite to C is RC, RA, RB, okay, and the Y is inside here, the red color, right? So R1, R2, and R3. So to transform from delta to Y, if you have delta, that means you have RA, RB, and RC, and you want to transform into R1, R2, and R3. So the formula is R1 is equal to, the way I remember this is R1, right, is connected to RC and RB. So I multiply those together, RB, RC, divided by the sum of all the R's in the delta. So RA plus RB plus RC. Okay, R2, where's R2? R2 is right here, right? So connected to at point B, terminal B, and it's connected to RC and RA. So you multiply these together. So RA times RC over RA plus RB plus RC. The third one, R3 is, of course, R3 is right here. It's connected to RA and RB. So RA, RB over RA plus RB plus RC. So this is a formula, okay? If you need, but in case of if you have Y, that means you have R1, R2, and R3, and you want to change to delta, okay? So the way I so-called remember this is that RA was RA is right here, okay? I would multiply those R1 and R2, R3, and add them together, right? So it becomes R1 times R2 plus R2 times R3 plus R3 and back to R1 divided by R1, okay? Because RA is, well, RA, the resistor that's diagonal to RA is R1. RB, same thing, the denominator, R1, R2 plus R2, R3 plus R3, R1 over RB. What's diagonal to RB is R2, so divided by R2. RC, R1 times R2 plus R2 times R3 plus R3 times R1 divided by, where's RC? RC is right here. Diagonal to RC is RC is R3, so R3. So these are the formulas, okay, to calculate, to transform these configurations. So let's see an example that we can show how this would make your life easier, okay? So, okay, let me put this right here. So an example, okay. $40, okay, and this is 125 ohms, 100 ohms, 37.5 ohms, 40 ohms, and find the current and power supply by 40 volt source. Okay, so I want to find this I. Okay, find I and power supply by the 40 volt source. So this is the questions, okay? And of course the middle here is 25 ohms, right? Of course, if in the future we have done up to voltage divider, current divider. We don't have any other method to solve. We haven't learned anything about mesh or nodal analysis, which later on, of course, you see this circuit. You can have, there's many ways, many techniques you can analyze a circuit. Okay, but let's say that right now we know only Ohm's law, dividers rule, and all of things parallel, and series connections, and of course the transformation, Y and delta transformation. Okay, so let's see here. So if we are doing this transformation, so the problem must be like I have to use it, right? So you can see that there's two deltas, right? Sort of like two delta share together, share the 25 ohms. Okay, so I'm going to transform. Okay, let's just choose one of them, one of the delta, okay, and transform this into the Y connection. Let's see that if the question would become, the circuit become easier to solve. Okay, so I'm going to change this 100, 125 and 25 ohms into the Y connections. So delta to Y, please. So delta to Y is right here, delta to Y. So therefore R1, where's R1? R1 is here, connected to the 100 and 125. So it's 100 multiplied by 125 divided by all the sum of the resistors in that delta. So 100 plus 125 plus 25, and the answer is 50 ohms. R2, Where's R2? R2 is right here, right? R2 is connected to 125 and 25. So 125 multiplied by 25 divided by, same thing here. So 100, 250, right? So 250 ohms equal to 12.5 ohms. And the last one, R3, is connected to 125 divided by so-called 250 equal to 10 ohms. So we have R1, R2, and R3. So we're going to redraw the circuit, okay, but into the Y connections. So 5 ohms. R1 is 50, right? And then go here. R2 is on your right side, 12.5 ohms, and this is 10 ohms. Okay, and then you connect it to the 40 ohms and the 37.5 ohms. So 40 volt and this current I. Okay, well you look, oh, it's still slanted. It's still slanted. What is this? Well, if you look at the way your current flow, please remember to make it a good practice. Okay, to analyze circuit, at least you have to know where the current in the circuit flow. Okay, so it goes like this, right? I go like this, come down here to 50 ohms, right? To 50 ohms. Then when we come to this point, it's split, right? Split into, let's say, I1 and then I2. Right, I1 goes on to the 40, right? I2 go past to 7.5, right? And they'll come to this point and go back as I again. Okay, so therefore, since 10 and 40 ohms have the same current passing through it, so these two are in series, right? So 40 plus 10 is 50, and I2 passing through 12.5 and 37.5, right? It become 50 ohms, right? So therefore, if you redraw it again, simplify your circuit, you would have 50 ohms, 5 ohms. This is 50 ohms, and this also 50 ohms, like this. Okay, 40. Well, of course, 50 parallel with 50, right? So it's like 50 divided by 2, 25. So you have 50, 5 ohms, and this becomes 25 ohms, 40 volt. I is still the same place, hasn't changed. We haven't changed or altered it, from the original circuit. It's still a current passing through the 40 ohms. So you realize now that you have all the elements connected in series. So therefore, I is equal to 40 over R total. Well, R total is, of course, 5 in series with 50, in series with 25. So 80 ohms. So 40 divided by 80 ohms. So equal to 0.5 amps. So that's 0.5 amps leaving the 40 volt source. So therefore, the power 40 is equal to 40 times 0.5 equal to 20 watt supplying. The answer is positive. The answer is positive, and the current leaves the positive side of the elements, that element. Okay, it means that this element here is supplying power, so 40 watt. So this is an example how you utilize or apply so-called WYE-Delta connections. Okay, so I'm going to show you another example. Okay, right. So give you a little time to write things down. So next questions. Okay, next example. Okay, use Y to delta to find voltage V. Okay, so therefore there. Okay, this circuit you may find later on, in several problems. The one that you have a resistor, instead of just parallel to 20, it's sort of like parallel to this node and this node right here. Okay, right. But later on you find another technique that may be easier to do. Okay, but in this case, I realize that I have a T, right? See, I have a T so-called configurations right here. Okay, I'm going to show you that I'm going to change it into delta. Well, okay, it's not exactly triangle. Okay, little curve. This, like this. Okay, so RA, RB, and RC. Okay, so I'm going to do it right now. That means use a formula, right, to transform what RA is. So RA would be RA equal to, right, equal to all the so-called, the combination of the multiplication of two resistors around that the T. So let's start with 5, right? 5 times 10, okay, right, plus 5 times 20 plus 10 times 20 over RA is opposite to 20 ohms, so 20, so equal to 17.5 ohms. RB, right, R1 times R2, right, see, R1 times R2 plus R2 times R3 plus R3 times R1, that combinations. So same thing, the one in the denominator is the same thing, right? So this one RB opposite to 10 ohms, the answer come out to be 35 ohms, and RC, right, divided by RC opposite to 5, so equal to 70 ohms. So this is your RB, RA, RB, and RC. So when you draw this, okay, so you would have the current source 2 amps, okay, right, so this is the 28, the original one, the 28 ohms, okay, but now you have RC right here, right, RC which is 70 ohms, right, RB is 35, sort of it's going to be like this, right, 35 ohms, okay, and of course RA, right, so it's 17.5 ohms. Look like this. Some of you may think, oh, what, but well, if we can redraw it again. Maybe you don't like slanted line, okay, connection is slanted, so you can draw it like a straight, so this point and down here, so you can think of it like this. Okay, so 35 ohms, and right, the same, it's the same point, no? Okay, and this is, of course, this is the same point. Okay. Oh, I'm missing. Oh, see, 105, right, and 75, 17.5 ohms. Okay. So you can see that, well, 28 and 70, right here, right, this here, they are connected in parallel. They're parallel to each other. See that? So you have this, okay, and you have, this is 35 ohms, and this is 28 parallel with 70, so equal to 20 ohms, and this is 105 is parallel to 17.5 equal to 15 ohms, and this is 2 amp. So therefore, we want to find V, which is right here. V is right here. Okay, we haven't altered the position of where V is. It's still across 2 amps. Okay, so therefore, right, if you sort of like simplify it furthermore, plus minus V, 2 amps, right? So this is 20 in series with 15, 20 in series with 15, and then parallel with 35 equal to 17.5 ohms. So therefore, V, right? So 2 amp passing through, okay? So 2 amp, so therefore V, this is parallel, right? So therefore V is also the voltage across the 17.5 ohms, so V Ohm's law, V equal to 2 amps times 17.5 ohms equal to 35 volt. So this is the idea of delta Y, Y-delta transformation technique, right? So maybe you'll find it useful in some of the problems that you will encounter in the future. Okay, so that's wrap up this topic. Thank you. Thank you.